Hi everyone, in this video we will see about the instrumentation and working of HPLC. So HPLC, it stands for High Performance Liquid Chromatography. It is also called as High Pressure Liquid Chromatography. Because the mobile phase is pumped at high pressures, it is also called as High Pressure Liquid Chromatography. So this is the entire instrumentation setup for HPLC. We have a monitor which is installed with the software, and this is the hardware of the instrument, and inside this we have sample tray to keep the samples, to keep the sample vials. This is the part where column is given, and we have a thermostat to maintain the column temperature. Now coming to the initial or first component of the HPLC, we have the mobile phase reservoirs. So these are the mobile phase reservoirs. We have two pumps A and B. Depending upon the nature of the mobile phase composition, one will be having aqueous phase and another one will be having the organic phase. So normally the organic phase which is used here will be having methanol or acetonitrile acids component. So this pump, the mobile phase from this two reservoirs will be pumped into the HPLC column through two small pipes. And since these are pumped under high pressure, we call this as high pressure chromatography. So once they are pumped inside, we have a degassing unit here where the mobile phase will be undergoing, will be degassed before it enters into the column. So when after degassing, the mobile phase will be coming here, and before flowing into the column, it will be going to the injection port where we have lots of sample trays which has lots of vials like this. So these are vials which have a nylon rubber cork over here. So the injector, since this is an automatic machine, during injection the injector will be coming here, and it will be this is the vial holder. So once the injection port is ready, the injection comes to this point and it will be moving here, and it takes the vial from this, and automatically the sample is injected into the system. So now the mobile phase which is coming through this two pipes will be flushing the sample which is taken from here by the injection port, and then it runs into the column. Now we have kept the mobile phase over here. So before keeping the mobile phases must be degassed, or it should be completely filtered. So for this filtration of the mobile phase, we have vacuum filter. So this vacuum filter is a setup where just pour a silica gel and a nylon cutter. So the mobile phase will be poured into here. So when this is operated, so the mobile phase which is poured here, it flows through this micro filter and it will be collected over here. So now this will be completely devoid of any impurities or any gas bubbles. So this ensures that the HPLC system is completely, the mobile phase which runs into the HPLC system is completely devoid of any impurities or any gas bubbles. So now the mobile phase which is flushing the sample into this column, it starts once the sample is flushed into the column, the sample separation occurs. The sample will be adsorbed onto the silica gel. So in the previous videos we have seen that the column is made up of silica gel. So it is packed with a tight coating of silica gel. So because of the action between the silica gel and the sample, the absorption of the sample will be taking place, and based on the nature of the mobile phase we use, the sample will be flushed out through the column. So once when the sample is coming out of the column, we will be getting a chromatogram like this. So this is the system is running, the sample is slowly coming out. So once the sample comes out, we will get a final chromatogram like this. So this is called as the chromatogram, and we have the point at which we get a sharp, the middle point where we have a maxima, it is called as the retention time. So once the retention time is found, we can compare the retention time of the standard and the sample, and we can find out what is the sample, what sample is given in case of identification. So now before, during the preparation, coming to the sample preparation technique, even if you are using water, you need to use millipore water. So we have a separate setup for millipore where the water will be flushed into it and it undergoes multiple members of distillation and filtration and we will be getting the final HPLC water. So now we will see the internal setup of an HPLC. So these are the two mobile phase chambers, as I have already said, two mobile phase containers. So one will be having the aqueous phase and another one will be having the organic phase. So from this, when the instrument is on, the mobile phase will be flushed into the column under high pressure. So now we have two which are going inside. So inside this we have the degassing unit. So this is the inlet, that is from the mobile phase reservoirs, the mobile phase is running into the degasser. So once it runs into the degasser, the gases or any other air bubbles will be removed in this component and then it will be coming out through this wire. So once when it is coming out through this wire, it enters into the system and it will be coming to the injection port. Since it is an automated machine, the injection port is hide over here. So once it enters into the injection port, the injection point will be ready and it will be coming out, it will be rolling out here and it takes the sample from the sample tray. So this is the wires in which the samples has been filled, and once when the injection point comes here, the automatic injector will inject into this and it takes up the sample. So once the sample is taken, the sample will be placed in the same point from where it has been taken, and then the sample will be flushed into the column through this wire with the help of the mobile phase. So when it comes over here, it enters into this port and we have the column which is attached here using a knob. So this is the knob. So where the column will be attached over here. So through this, the sample along with the mobile phase will run into the column and here the separation occurs. So this column is made up of silica gel. The column is composed of, or it is packed with silica gel. Based upon the nature of the silica gel which is packed inside, we have C18, C8, C36 column, etc. We have columns which are meant for both analytical use and preparative purposes. So the preparative purpose column, it merely is used for separation of the components before analyzing by using the analytical column. So once the sample is flushed into the column by the high pressure mobile phase, the retention or absorption of the compounds will be taking place and it will be coming out through the other knob. So when it comes out through the other knob, the extra mobile phase along with the sample will be flowing over this and it will be flowing to the waste. Once the sample is getting eluted, we can see the chromatogram as shown in the previous video, or I will show you now also. So when the sample starts coming out, we will be getting a chromatogram, or the chromatogram or the graph will be seen like this. So when the sample is coming out, we will get an increase in the A naught, etc. So once the sample is completely eluted, this graph will be coming down and it reaches a plateau state as shown in this chromatogram. So this indicates that the sample has started eluting out of the column and it has reached the maxima, and then entire sample has been coming out, is shown by a plateau region. So this is how we separate the components by using HPLC. So now we have the reductor which is placed over here. We have two types of reductors. One is bulk property reductors, another one is solute property reductors. So normally in all the HPLC which we use nowadays, we have a solute property reductors. That is reductors which are like, for example, PDA reductor, photodiode reductor, because based upon the nature of the sample, we can scan the sample or we can set the wavelength of reduction at various wavelengths. UV visible spectrophotometer reductors, we have fluorimetric reductors, electrochemical reductors. So when this is attached to an MBUS or mass spectrometric or mass spectrometry, then it becomes LC-MS system. So MS mass system, mass spectrometry is a hyphenated technique of this, but when it is attached to an MS, it becomes an LC-MS, a hyphenated technique. So this is the internal components of HPLC, and along with the software which is installed here, and here we have the Agilent system. The make of this HPLC is Agilent. I think this video could have given you an idea about the instrumentation of HPLC. Thank you.